Hello, class. This is Steven Zawicki, and I am here to help you test your models for your pendulums. Now, what I want you to work with, the data set that I want you to work with, is the relationship between length and period, since that is the one that is clearest. We have a small relationship, a small positive relationship between angle and the period, but there's not much of one. So the first thing that you're going to do is you're going to look at your graphs. Okay. So here's my length versus period. And let's say we measured this in centimeters. Okay. Now, you had 3 different points for length, and that gave you 3 different periods. So let's say we had 2 points here on different ends of our graph. So the first point we find is in between, let's say 30 centimeters, and it was 1.5 seconds. And the next one was 50 centimeters and had a time of 2 seconds. Okay, so I can place that dot there. And then what you should have done is you should have made a line of best fit in between your points. So let's say my line of best fit goes through both of those points so I can use it. We want to find the slope of this line. So you might remember that it's the rise over the run. And this is equal to mathematically as y2 minus y1, right? That's the rise, that's the up and down. And then x2 minus x1, okay? So let's plug in our values. Let's find out what it is. So we have a y2 x2 of 1 minus 1.5. And we have a x2 y2 or x2 x1 of 50 and 30. Okay. So I do the math. I find out that this is 0.5 seconds over 20 centimeters. Now let's simplify this out a little bit more. We find that that is going to be 1 second for every 40 centimeters. Okay. So it's a nice, easy fraction. So this is the first part. This is how you find your slope. We're going to move on to the next part, which finds our y-intercept. So in the y-intercept, what we need to do is we need to fill in all the unknowns in our linear equation for a line. But first, let's write that down so we know what it is. So the equation for a line is y equals mx plus b. Now the m is the slope, so we can plug that in. We said it was 1 over 40 centimeters. 1 second per centimeter, or 1 second per 40 centimeters. And then the x and the y are any point on our line that we can fill in. So we already know 2 points. So let's plug in one. We said that we had 50 centimeters for our x, and that gave us a y of 2. And we are left with one unknown b. Now we're going to have to do a little bit of algebra to get there. So let's do that. So the first thing that we're going to do is we're going to multiply the 1 over 40 and the 50 together. So we have 2 equals 50 over 40. And notice how we are left with seconds, right? The centimeters cancel. All right, so we have 50 seconds. 50 over 40 seconds equals 2 plus b. And now we can subtract that onto the other side. So it's 2 minus 50 over 40. Equals b. And so whatever we have left is going to be our y-intercept. So calculating that, that's going to be 0.75 seconds. So this is our y-intercept. So now that we have this, we can plug this back into our equation so we have the full thing. So it's going to be y equals 1 over 40 x, and we want our units, seconds per centimeter, plus 0.75 seconds. Now, y and x is really general. We use that for math. We do need to change things around. We want it to be in terms of our actual graph. So on the y-axis, we were plotting the period, capital T. Then we have our 1 over 40, just like we did before. seconds per centimeter. And on the x-axis, we were mapping the length. We were graphing the length. And then we add in our 0.75 seconds. And this is our total equation. Okay, I went through that kind of fast. Take some time, look through the different steps, come to the office hours if you need some help. I'll see you later, class.